Welcome to the first Houdini Quick Tricks tutorial from 9between. And this is a new format that I'm trying. It's for our $15 patrons, because at the moment all of our content is quite saturated in our top tier. In this tutorial we go over SOP solvers and constraints, and how they work together and how you can use them in DOP networks. So this isn't an actual setup creation, but rather a guide as to how you would go about navigating SOP solvers and constraints. So if you like this format, please let me know. I will be releasing a couple more of these, so hope you enjoy. So currently what I have set up in Houdini is a very simple Vellum setup. So I have this skull geometry, polyreduce it a bit, and then feed it into a cloth. So we have some bend, some stiffness, and nothing really crazy going on. We also have some struts. So if you set this to wireframe, you'll be able to see that we have these struts inside of our geometry. So these struts provide structural integrity for the skull, and all I've done is reduce the max strut length because originally it is at 100. I just dropped it down to 1 so that it does not create struts that are too long. And basically that's it, just increase the stiffness. And the last constraint that I have is a Vellum pin to target. And so I can just recreate this one quickly for you, just so you can see how it works. So you drop down a Vellum constraints, plug it in over here, right? And then you change it from distance along edges to pin to target. Now what this does is it pins all of your points in this place in space. So if you run the simulation, your skull will stay pinned to these points. So as you can see here, we have pin type permanent, but we would like to change that to soft. So now that it's set to soft, it has the option to bend and to break. We just need to enable breaking. So we can enable breaking, and a threshold of 0.1 is fine. So now what we have here are a bunch of points that are pinned. We also have some internal struts that are holding things together for structural integrity. So when we play this back in our simulation, our skull should now just stay in place and not move at all. So what I'm going to do is just output our geometry from our Vellum into this null called geo, our constraints into this null called const, and then I'm going to take our constraint geometry and plug it in on this side. And what I have over here is a simple growth solver setup. So I set up a growth point, it's 0.0, you can see it over there, it's red. And then you run the solver on it, and it grows out from that point. And then all I do is change the name of growth. So I say @release equals growth, create an attribute promote, and I promote that release attribute from point to primitive, and then I just have this release output. So remember, Vellum is split into geo and constraints. So I'm taking the geo over here, I'm taking the constraints over here, and then I'm also taking a changed version of the constraints. So I'm taking those constraints and I'm adding a release attribute on them, so that as this grows, you have this release attribute. So now how would I use that? So let's go up a level into our dynamics network. So here we are in our dynamics network. I'm just going to jump back to the beginning, change this from wireframe to smooth shaded, or rather smooth wire shaded. So in here, once again, very simple setup. It's a Vellum object, Vellum solver, a Vellum source, and a pop wind with a ground plane and gravity. So you can imagine what happens because we have it pinned, it won't move, and it just sits there, right? So nothing crazy is happening. And if we disable our pins and then try this again, you'll notice that it falls. But now what happens if we want a middle ground? Right? What happens if we want our pins to be deactivated based on this growth that we have, based on this release attribute? Well, that's where you'd use a SOP solver. So what we can do is drop down a SOP solver and drop a merge node. So you take your SOP solver and you plug it in with your Vellum source. This Vellum source is taking our geo, so that's the skull geo, plus our constraints, right? Now something that this Vellum source does is it binds it to a geometry type. So if you go over here into bindings, you'll see that it says geometry, and the name for our geometry is geometry, and our constraint geometry is constraint geometry, and then you can ignore patch geometry for the most part. So what does this mean? Well, we know that the two sources that we have are geometry and constraints. And what it's doing is it's naming those. So we have two named geometry types. We have geometry and constraint geometry. And if you go over to your SOP solver, you'll notice that it says geometry over here. That means that it's currently running over geometry. But your other binding is constraint geometry. So if we change this data name to constraint geometry, and it's case sensitive as well, you'll see that that changes over there. Now if we dive inside, what we can do is actually make a few changes to our constraints. Because now what you'll notice is when you're out here, you see this, but when you dive inside, you actually see the constraints. So this is dependent on what your data name is. If it was just geometry, you'd dive inside and see geometry, but because it is set as constraint geometry, you dive inside and see constraints. That means that we can adjust our constraints from here. So if we had to do something like object merge, we can now work with this as if it was on the SOP level, because the environment that it is now working in is no longer a dynamic environment, but rather a SOP environment. So you can actually just take your release node over here, and if we take a look over there, we can see it's that node that we created earlier. And so how would we transfer that onto our geometry and then affect our geometry? So what we can do is do an attribute copy. And attribute copy is actually very similar to attribute transfer, except it doesn't work with distance, it works with topology. So if you plug this in here and plug your object merge in here, we can actually transfer our release attribute, right? So now we can drop down an attribute wrangle and change it from points to primitives, because remember, constraints are primitives. Constraints are not points, so we need to make sure that all of the work that we do on constraints are done at the primitive level. So we change it to run over primitives. Then in here, we can just say something quite simple, like if at release greater than 0.1. So if we have that release attribute moving over our points, then do something. So what would we like to do? Well, we would actually like to release points. So we would like to break those pin points. So to break pinning, we say at break threshold, and you can actually find this here. You can bring up your geometry spreadsheet, and right over here you'll see break threshold, break type, damping ratio. These are all the attributes that are actually on your constraints. So you can check over here, we have a break threshold of 0.1, and that's what we set earlier. So what happens if we say at break threshold equals 0? So now we're saying if that release attribute is greater than 0.1, set our break threshold to 0. In other words, break it. So now if we play this back, you'll notice something pretty cool. Those constraints are being broken. And that structural integrity is from those struts that we have. That's a constraint that isn't broken. It does not have a break threshold. If we play this back, you can actually see that the skull's detaching. It detaches over time, and it falls. And that's very useful for a lot of things, because you can actually have something that looks like a solid and then collapses into a soft body. And so on here, it's very useful to become comfortable with the type of attributes that constraints have, and you can actually drop down a constraint property, and you'll see Vellum constraint property, and I'm not going to connect it to anything, but you can take a look at all of the different attributes that you have. So these are all the attributes that a constraint can possibly have. So as you can see over here, here's that break threshold, and it says over there parameter break threshold, and that parameter where it says break threshold is actually the name. So you can call that attribute by saying at break threshold equals, and then you can assign a value. Some of these are read only, so you can't change their values, but a lot of them you can. So for example, stiffness you can change. And you can change most of these, such as rest length as well. And you can do all sorts of things with this. Something else that you could do is perhaps adjust your rest length. So let's go onto our class setup, and on our constraint, let's add an attribute. So drop an attribute wrangle, and over here, let's just say @shrink equals @rest length divided by 2. So as we know, our constraint has a value called rest length, and you can find it over there. There's your rest length for each point. Now what we've done is we've also made an attribute that we need to actually set to primitives, so change from points to primitives. That's called shrink, and it's half of our rest length. So now we can go ahead, back into our dynamics network, back into our constraint network, and over here we can also just shrink points. So we can say @rest length equals @shrink. So what this will do is, as points are released, your rest length for those constraints also decrease. So if we play this back, you'll notice something a bit different now. All these points are contracting in. So the pins are being released, and we're shrinking all of our rest lengths. So rest length is just how long your constraint currently is. We're actually shrinking all of our constraints, and the whole thing pulls in towards the center. And so it crumples. And you can do all sorts of cool things with constraints, and these are just a few that I thought I'd show you. So this is just how you would use a SOP solver to adjust your constraint geometry. So that's just a quick tip related to our tutorial that was released last week, and we're releasing the next part of that tutorial soon, which is working on a few things at the moment. But this is something new, and if you like this sort of setup and you like these sort of quick tips, please let me know and I'll try to release more, because I am trying to improve our other tiers at the moment. All of our content is kind of saturated in our $29 tier, and I really want everybody to actually be able to have access to these things while still making our upper tier more attractive. So, thanks for watching, hope you enjoyed. See you next time.